Hello everyone. Start a course on VLSI technology. This course is a comprehensive course which will give you details about VLSI industry as well as the theoretical concepts on VLSI also. So, what do we need to do to complete this course? So, first, we need to understand the basics of electronics, which especially digital logic design and also some aspects of analog. I'm hoping that you all are aware of electronic at least to certain extent, that is a digital electronics as well as analog electronics. So with that in mind, we will start this course. If you find that you're not well aware of certain concepts of analog electronics and digital electronics, you can always go back and look at some concepts. But since VLSI technology course is more towards the digital side, this course I will be telling you about some digital aspects. So with this perspective in mind, let's start the course. Okay, so what are the objectives of this course? The objective of this course is to understand the chip design process. So what do you mean by chip design process? The chip design process is nothing. It is not just like you get a chip from some place and you start doing some design process on that one, or you draw some circuit on that one and connect few voltages and it works. No, it's a very complicated process and the process takes quite a lot of time. Nowadays we all know that almost every 3 months we have a new mobile being released with different kinds of configurations, and every mobile shows itself better than the others. So as you see, the time to market for these mobiles is so less. It is hardly 3 months or 4 months. So what we will understand in the first two modules is what are all this about. So we will also understand how does the chip design process takes place. Okay, and also the other aspect of the objective is application of the theoretical knowledge. Yes, most of us might have studied electronics course in our engineering, and that electronics course will consist of so many different kinds of subjects. As we also have VLSI as one of the subjects. We have VLSI, we have analog VLSI, but how many of us know what is the application of that VLSI theory? How many of us know how to use linear circuits in VLSI? How many of us know how do we use digital logic design in chip design process? We know how to design counters. We know how to design sequential circuits. We know how to design state machines on paper, but then we don't know their practical applications. So that will be another aspect of this whole course. The another thing is, yes, talking with you about the first aspect, that is to bridge the gap between students and the VLSI industry. The moment we complete our electronics course in engineering, we are left with no option and we just don't know what goes on in VLSI industry. We all know we are very much well taught in our engineering about C courses, some programming languages, a bit of Verilog, and very minimal VHDL. And also in certain colleges, FPGA programming is also taught. But then VLSI industry is not just about Verilog, VHDL, or FPGA programming. It is a wide array of different domains. So we'll see what are all those. So now let us see table of contents, that is what will this course consist of and what is this course all about. So first topic will be introduction to VLSI. So introduction to VLSI will have two modules consisting of one is the theoretical concepts and another is the some practical terms that are used in day-to-day industry life and some new methodologies also. And the second module is VLSI domains in industry. So we have different VLSI domains in industry. I know that it'll come as a really new information to lots of people that VLSI itself is a domain, but then in VLSI there are different kinds of branches, and when you get into VLSI industry, you have to make a different profile. It's not like you are a VLSI engineer overall. It's like you have VLSI blank engineer. That is a different domain, a different kind of work is there for every domain. Okay, and third topic will be an overview of digital logic design. that will be that will consist of some basic theory concepts of digital logic design from the viewpoint of practical applications. And fourth one will be basic CMOS technology. So basic CMOS technology will consist of how a CMOS is made. Yes, how a CMOS is made, that is from the design perspective, and how it is used. Next, timing is very important. As we go further, I will tell you more about timing in circuits. So we will dedicate a whole chapter for this work, static timing analysis in circuits. And next comes very important, that is Verilog programming and synthesis. We all know about Verilog programming, that is RTL, register transistor language, and but what we do not know is its synthesis. So Verilog programming and synthesis will go hand in hand. Next, design and verification. Design and verification is one of the domains under VLSI. So we will be studying about design and verification and the various methodologies used and various methods used in that. And there is another domain, that is physical design, layout design, and rules. So even this is one domain that we will be studying. And next is testing of designs, that is design for testability, DFT basically. So design for testability also is another work domain in VLSI. So we will know what is it about. Next, and the last one will be VLSI fabrication steps and industry. VLSI fabrication and steps and industry will give you a small amount of details into how a fabrication lab manufactures a chip, and what are the methods, what are various processes used. We will get a slight peek into it. So with these modules modules and chapters in mind, we will start our course. So first module will be introduction to VLSI. So this will consist of two submodules. The two submodules are, one will have the theoretical concepts and another will have the practical concepts. In the second module, more than practical concepts, we have something called as practical terminology or practical terms. What are the new methodologies? What are the new practical terms being used in VLSI industry? It is just to make you a bit well versed in the industry terminology. First, we will start with the theoretical concepts. So theoretical concepts we will start with a very basic description of what is MOSFET, why MOSFET, and how does it work. So as we all know that MOSFET is metal oxide semiconductor field effect transistor, right? Yes. So this metal oxide semiconductor field effect transistor is the new generation, or you can say is a successor of BJT, that is bipolar junction transistor. It's also a successor of FET, field effect transistor. So we can ask a question for ourselves: why are not BJTs being used, and why do we use MOSFETs instead of BJT? So we will come to know all those things in further slides, and we'll also study how it works, how a MOSFET works, and what aspect of the operation of the MOSFET do we use for practical applications. Okay, so with this in mind, we'll go to the next slide. Okay,